So we're 3D HCI, which for those of you who don't know is human-computer interaction. Our idea, as we'll get into more, is bring a touchscreen-like experience to a three-dimensional space. So I'm Jake Lowy.
I'm John Bergen.
I'm Eric McBunnis.
So our concept is, in general, it's just a glove that can be used in place of a mouse and keyboard. Like if you're just on the couch watching Netflix and you want to change it to a different show, but you don't want to move. So you can just go like this and change it. It has been tried before, such as the NES Power Glove, which was done in 1989. It had motion sensors and buttons. The issue was that it didn't really work very well, and it only controlled the Nintendo Entertainment System. More recent attempts at this, there was like the Key Glove, which has motion sensors in the glove and also touch sensors on the hand. And the Peregrine only has touch sensors, no motion. But the big question is, how is ours different? All three of those gloves on the previous slide were designed for gaming. Ours is not necessarily designed for gaming. Ours is more for just web surfing or controlling Netflix or YouTube from the couch or the bed. We have basic design sensors. We don't have touch sensors. Instead we have flex sensors in the fingers. And we have an accelerometer. And there's very little learning curve because you just have to learn a couple gestures and then you'll be fine.
So as far as the hardware goes, we decided to use an Arduino for easy prototyping. When it comes to the flex sensors, there's one on each finger, which basically means for each finger you have open and close. So that's like 2 to the 5th different gestures that you can do without just with your fingers. So that's like 32. Then the accelerometer, it also tells whether it's in portrait or landscape, which basically, and also different motions that you make. So the number of gestures and as well as like movements that you can make your commands like infinite, basically.
So software, as this is RCOS. It's written in Arduino, so Arduino C, C++, and C++ on the computer. The Arduino code is strictly to transmit data because we didn't want to do any of the processing on it because it's not nearly powerful enough in order to do all the processing we need. So the C++ code interprets that data and acts accordingly. So in overview, we read in from the 2 different sensors, the bend sensors or the accelerometer, and then, or the gyro, more specifically, because it can't interpret, as you said, landscape versus portrait. And then transmits the data via, right now, a serial connection, possibly Bluetooth in the future if we want to, it's a battery operated, to the computer. And the C++ code reads in the data, interprets the gyro data to control mouse motion, and data from bend sensors for key bindings. Right now, we're going to be hard coding in key bindings, but we'd like to in the future be able to replace them with something a user could determine. And special thanks, as always, RCOS Professor Goldschmidt, Marthy, and Sean Sullivan.
And now you have some code you'd like to demo?
Yes. So, right now, we're working on very elementary stuff, so it's mouse control. I don't know if you're going to be able to see my mouse control. Oh, there we go. So we have a bounding box, mouse control, and as well as a serial connection, which right now is not connected to anything except for the COM3 port, which is just the Intel port. But it does work with serial communication. That's what we wanted to show off.
Thank you.
Any questions?
Do you see any potential use of this in the future for something like sign language to text technology or something?
Okay, the question was, do we see that we can use this for like sign language to text? And yes, actually, we thought of that, putting touch sensors like the other gloves, and that's something we can implement in the future, but as of right now, we're just trying to get motion and being able to use mostly a mouse, not as much a keyboard.
speaking more on that, I believe some RCOS group in the past couple of years did try that. And so that's just not really the intention of what we want to do.
How far along are you on hardware? Like, what's kind of the scope of work for the summer timeline?
Okay, the question was, where are we on hardware? And
Right now, the hardware, we have all the hardware. We're just working on making sure we're testing it correctly before we actually solder it and put it onto the glove. We do have a glove. We bought a golf glove actually because they flex well and they're easy to sew to.
only the highest quality glove from Walmart.
So we do have all of our hardware and we're working on that. As far as the summer goes, we'd like to have that completed by next week so that we can get into more of the prototyping.
I just want to start off by saying that I actually did something somewhat similar for my own project, like a golf glove with flex sensors and a 9-degree freedom iron with a teensy instead of an That's a lot smaller. And so if you're trying to use the accelerometer, I would use more of just detecting gestures broadly and classifying them because you really can't get accurate position out of them. But if you want like any help, it's open source and I can talk to you guys later.
Oh, okay, thank you.
Yeah.
Any other questions? Okay, thank you.
Very much.
Can you have a helmet and then the sensors, okay, just the sensor have to be just a cloud, to the connected to a cloud. So in other words, if a person does not have a hand coordination with this person, how flexible is it will be that work? Do you understand the question?
Like, can you have a helmet where you like flex your head?
Yes.
I don't see why that couldn't work.
Yeah.
It might not be, you might not be able to have quite as many gestures as your head, but yeah, that would be able to work.
Yeah.
Thank you.
Next, we have Alex White presenting on why to use functional programming, or why functional programming.
By the way, those of you who are presenting, please post your slides to the group or post the link to the slides to the group. So that will be very useful.
Okay. This is just a general talk about functional programming. I know that when I first tried to learn it, it didn't make any sense to me because I didn't understand why you would want to use it. And if it's any consolation, it's still not as big of a ship as Prolog. So in any case, there's a wide range of functional and there are two main paradigms of there's functional and imperative. Most of the other ones fit under these two in some regards. Imperative languages are the ones that are taught at RPI right now. Of course, there's a lot more on both sides, but these are the main ones grouped by family. Anyway, what I won't talk about. Well, I'm probably wrong on at least a few things here. I'm not going to mention that. I'm not going to talk about Swift because it's an Apple language and I can't stand them. Because they have terrible syntax and they combine all of the unintuitive languages together. Or they combine all of these easy languages into something much less simple. So now you end up with something that resembles a combination of JavaScript and Bash. Anyway, there's also that schism between people who believe that functional programming is the way of the future and people who believe that it is pointless. It is pointless. That's also not pointless. So what's different about a functional programming language? I mean, largely it's a question of whether or not data is mutable. and whether or not you're encouraged to modify it. In C, you create a variable and you always end up assigning. You end up reusing it several times probably. Whereas in a functional language, you never alter it. You instead just assign a new variable as it's transformed by functions. Hence functional. Most functional programming languages have higher order functions or second order functions. Anyway, you can pass functions to other functions so that they're called by that function and they do stuff with other data. That's very useful for working with lists.
So you can say that the granddaddy of all functional programming languages is lambda calculus.
Yes, that's later on.
Okay,
That's
we'll go
later
to
on. Okay, now all of this stuff requires a large shift in how you write your program. But there are benefits, probably. It really depends on what program you're writing, but in general, you can expect a simplified program design due to the immutable data. You can expect if you do your functional programming very functionally, pure as possible, you're never going to run into concurrency issues if you decide to make it concurrent. And most functional programming languages do their best to make code simple. I can't remember any of them that I listed that aren't so, unless you count them. And you can also expect garbage collection because really, if you're doing that manually is something that's best left for an imperative statement because that changes the program statement. Right? This is an example of a ridiculously trivial function. Iterates through a list, adds 3. Vocals on that side, it's less than half as long as the C++ code. Notice the lambda function here. That's what he's talking about earlier. Wait, another one because you'll notice that you can't really see all of the C. I think that's probably preferable. Oh, and I misspelled Haskell. Okay, this is the last example, but this is from the project my group is working on. It computes a grammatical closure in order to build a parsing table. And this will take hundreds of lines of code in another in an imperative language. So again, why should you use this? Well, there's not really, you can't really quantify the benefits consistently because it's a program by program basis, but in general, it's likely that if you try programming something functionally, that you can have issues with imperative programming, then you might have an easier time. Or at the very least, it'll loosen up your brain a bit. Datum. So, more about immutable data. State is changed entirely if variables are changed at all, they're generally only changed in what they refer to. Functions apply transformations to these variables and return the altered information. Side effects should not exist. Altering information by pointers in C or C++ or reference types is most likely not functional. Side effects are bad. You should be careful around them. They're useful when you know that they're coming, but if you're careless, then you're going to probably end up doing something wrong. Anyway, probably actually all had that if you take data structures recently. You probably dealt with the misuse of side effects. And actually the definition of side effects is given by the C++ 11 specification in regards to the lambda functions. that they just added. And it pretty much covers all of the things you would expect a functional programming language to be careful about. The biggest one here is probably this one. Especially since we're adding more processors instead of faster ones. If you have avoiding side effects makes turning your program into a multi-threaded one much simpler. Well, now if this sounds good, then you're still going to end up using some imperative parts. Most things like input and output are probably considered imperative, even when inside of a functional programming language. Functional programming languages suffer from the malady of being fairly slow compared to C or C++. Especially Lisp, but that's because it's not compiled the same way. Lists are linked lists, which means that you can concatenate them as much as you want, but if you want to do random access, that's very expensive if you're going to be iterating over a large list. And if you do spend the time and learn one of these functional programming languages, it's fairly, they're very rarely used in enterprise software or production grade software, simply on the basis that there's generally not as many libraries for them, and the libraries there are generally.
But I think people do use functional programming without their knowledge somewhere. If you think of LaTeX as a programming language, what you have a markup document, you do some interpreter there, you don't have any side effect or do some side effect. But I think there may be places that people use functional programming without that knowledge.
Well, actually, one of the few places where you still find ML used is financial industry, surprisingly enough. But I mean, you're still relatively unlikely compared to you're more likely to be writing C or C++ compared to Lisp or OCaml. But anyway, there's a lot of benefits that you can get out of this if you learn to use it properly. And it's not in the language; it's in the paradigm. You can do it in C or C++. You can't do it. It's harder to do in Java, but you can do it. There's not so much of a limit that you have to worry about as far as languages go. Anything that's any reasonable language is probably going to suit your needs. And immutable data is the devil. That's it. Are there any questions?
Yeah. The introduction of Swift by Apple, do you think that you'll be seeing much more functional programming in the enterprise? In general, besides the field?
I feel like the syntax is going, it's great that they wrote another language, but the issue that I always see with all of the Apple languages, whether or not they try for it, is that their syntax is ugly. If you see it in Objective-C, you see it in Objective-C++. I mean, when you refer to an option, a variable arguments and a function in Swift, you use a $sign with the number next to the argument, and that seems unclean. It reminds me more of Bash than it does of any proper programming.
Well, it would remind a lot of programs to use it as PHP.
Yeah, I have similar views about that. You also notice that I didn't mention PHP at all. Any other questions?
So regarding the speed of Lisp, is it, like according to that Norfolk benchmark, is common Lisp like within a factor of 2 of C++?
Yes, but I mean, that's still slower, and if you don't,
But that's better than things like Java and Python.
yeah,
Significantly better.
I didn't mention either of those in the performance because that would have negated the point that C and C++ are generally just very fast.
Which version of this are you referring to?
I'm not sure. I think it was probably SBCL.
Okay.
Anything else?
That would have a big
You want the right color.
Yes, in fact, to overcome the slowness of Lisp, they had, long time ago, they had Lisp machines which will execute Lisp programs directly on hardware. So that is what Lisp machines were very popular in early 1980s.
Anything else?
So the chart on the first and second slide with the languages, you have them separated horizontally by what their dominant paradigm was. But there also seems to be a pattern in how they were separated vertically.
Well, I mean, they were separated vertically by the paradigm, but not
Okay, so then
and then they were grouped horizontally by their syntactic conventions and which one they took after.
okay.
Anything else?
And also about the libraries issue. For things like, I guess, Scala or some scheme dialects that run on the JVM, and I guess with F# or .NET, does that do those still have the problems with not having many libraries?
It's a different kind of support. There are a great number of companies that are offering performance solutions for C or C++ for whatever obscure fields that you want to work. If you want to really classify koalas or something, koala hair, based on its roughness and whether or not it's been shampooed recently, you're not going to have a library for that. You're probably not going to have a library for that in a functional language. Actually, I kind of hope that library doesn't exist at all. But there are a great deal of libraries for anything that's not esoteric. Are there any more questions?
So actually, about the libraries, fairly straightforward to access the code from OCaml.
Yes. Is that universal to functional languages though?
Okay, never mind. So that's not blue general.
Okay. Is that it? Thank you.
Answer your question, but even one. Like,
I'm actually going to be
that's
presenting
pretty much why
now.
JV languages is a big part of like why this is like closure and Scala, like they pretty much solves like a lot of library models. The only problem is that you're not keeping the same convention of that language, but since it's within a controlled area anyway, now you use it there. It's not like affecting like you are still not like making all the state changes. And then what they're doing is pretty much already done, right? It's mutability, big problem mutability scalar, but that's already done for them. Like can't really. So yeah, you should look at the JVM. Also, like in Scheme, Guile Scheme is pretty great.
So my project's called Hackadex. I'm pretty sure all of you know who I am. So Hackadex is basically a project index, and it's a tool for developers and recruiters. So obviously you might say, well, what's a project index? A project index, in this case, is essentially a search engine for data. And it's going to be focusing on data coming from open source projects. So it can, in the future, come from a variety of sources. Right now, it's coming strictly from GitHub, where there's obviously a lot of open source projects and already a lot of data associated with projects that can retrieve from the API. On top of that, I'm adding additional data that the user, so either someone, an owner of a project, or a user who's potentially going to contribute to a project can add to a project. And then parse tools, so I can essentially sort through code for projects, figure out what libraries are being used, if they're favoring some kind of behavior, and then just essentially aggregate huge amounts of data that will allow you to match a developer to a project that fits their coding style, libraries they're familiar with, code they've worked on in the past. So there's a little more than that though. So if you're a user, a developer, you have the ability to follow a set of attributes. So you can say, well, I want to program C++, and here's a list of libraries I know how to use. And I want to learn how to use this library, and I really like inline assembly. And then it could literally spit back all of the projects on GitHub that fit all those characteristics. So it's essentially an enhanced search engine with its own website and the ability to add additional data to what's already retrieved from the repository itself. And it can generate essentially a CV or a report card or a transcript or whatever based on your performance. So all the projects you've contributed to, the technologies you've used in those projects, basically taking what you get if you look at the statistics from GitHub, and instead of focusing on quantity of commits or frequency of commits, it's going to focus on what technologies you use, which ultimately is a much better indicator to a company whether or not you'd be a good fit for their development. So it allows someone, a recruiter at a glance, to see whether you're familiar with the kind of technologies that you have to be using there without them having to sort through your code. It's not exactly a replacement for Observatory, but it's kind of a similar project in that it is an index of open source projects. It doesn't do ranking though, and it's focused on matching users to projects instead of encouraging users to work on projects. So it keeps track of matched user contributions. So if you are matched to a project, it'll then see how good of a match was it you actually contributed to that project, and if so, were you contributing in the manner that it expected you to. And it's a single global website instead of something that would be deployed on like a college campus or a group. But it does have the ability to add location attributes. So if you want to work on open source projects that are based locally, either within a college or within a geographic area, you can add a tag for that. The real point of it, though, is to match people who have no idea what they want to work on projects. So it finds projects that are similar to an idea and encourages collaboration by either finding things that are basically already what you wanted to do, so you can just contribute to an existing project instead of writing it all from scratch, or finding pieces of code that you can use in your project because they've already implemented large chunks of code. So it works with a Python backend. Initially, it's actually essentially functioning as a search engine and doesn't store tagged data locally. That's going to become later this summer. So it pulls project information from GitHub. Initially, it's basically you type in a search query and select whatever attributes you want to search by, and then it executes the API calls needed to retrieve that data. In the future, there's actually going to be a database with all of these attributes stored, so it doesn't have to keep calling the GitHub API. And that also allows us to add additional attributes that can be retrieved directly, because that's really important. And it allows you to import some profile information from GitHub and tracks all their projects, even ones that they weren't matched for through Hacknet's tool. And it allows project owners to add additional information. So I'm going to be doing something different from what most people in RCOS do, and there's going to be a live beta every 3 weeks. So I'm focusing on adding very small features and getting it like entirely production ready in a short period of time. So the first beta, which hopefully will be out next week, is basic search functionality and attributes. This is just doing the direct API calls. 3 weeks after that, there'll be a database and some additional attributes being stored in it, but the database will be populated on demand for all of those API calls until essentially the entire database is full and it's just maintained. After that, user profiles, and then finally report generation. And that will pretty much be the summer. So that's what I have. Next to the usual suspects. I look for your feedback since this is something that ultimately will be benefiting groups like RCOS directly. Okay.
Do you think it's possible this could go in the direction of some sort of I don't know, how there's like online program learning websites, like where you just go online and you want to write code for 5 minutes so it type in what you know and it gives you a little snippet to work on?
It could.
More of an in-depth, like, I want to do something for summer, let me look around and GitHub and see what I can work on.
It's It's a little more of the latter, just because if you're going to be contributing to a project, your code needs to work. Other people need to verify it works. If you're writing code for 5 minutes, the overhead needed for someone else to verify that that code is actually beneficial to the project will significantly outweigh them just writing the code themselves.
Okay.
So it's really just to help match people to a project that they'll want to work on for a longer period of time. But it's to help people find projects that already exist instead of them starting working on a project from scratch when they might already be really good platform development.
Can you run this concept of GitHub, whether anybody else has attempted to do this?
In theory, actually, when I just discovered this morning, I bought the Hackadex domain a while ago. I got it out of an auction because I thought it was something cool domain. It turns out Hackadex was actually a project index like 4 years ago. Never got anywhere. It was closed source. I have no idea what it did. From what I could find out of their Twitter, it was kind of similar, but focused more on instead of matching people to open source projects, just being an index sort of like observatory for closed code.
There was a search engine called code.google.com
Yeah.
or something. You can do a code search.
Yeah.
So what does that do? How does it happen?
Well, the code search works with just the code hosted with Google. Ultimately, what this is doing is not being a search of code, but being a search based on a lot of rich attributes. So some of those attributes aren't even directly coming from code. Instead, it's size based on various, parsing through the code, aggregating what libraries we use, that kind of stuff. But it's really just a simple, nice interface for retrieving this kind of match. You could probably do, at least for the first half of the summer's work, you could get the same results by